Hey friend, it's Colin from SonicScholar.com. Welcome back to our C# data structure series. In our previous video, we talked about array lists and implemented a generic iSimple list of T interface. Today, we're going to dive deeper into data structures by talking about linked lists. Now, I'm going to start off with a confession and say that I have never needed to use a true linked list in the real world outside of academia. And you might be wondering why we're bothering to learn linked lists if they're not commonly used in real world programming. So while it's true that linked lists are not as widely used as other data structures, they're still super important to learn because understanding linked lists will provide you with a solid foundation that's needed to understand other node-based data structures like trees, heaps, graphs, etc. In fact, the title of the video is clickbait because a linked list is just a very specialized version of a graph data structure. So I should really call this video Introduction to Graphs. So what is a linked list? Simply put, it's a data structure that represents a sequence of elements which consists of a root node that points to the next node in the sequence and so on. This is so easy to understand that if you've ever played a telephone game when you were younger, you're already a master of linked lists. But now if you want to become a master of object-oriented programming, which is foundational to being able to build out a linked list and other data structures, I have something that can help you out. It's my C# object-oriented cheat sheet, which covers all the good stuff like classes, objects, references, interfaces, etc., all that. The cheat sheet is condensed into just 8 pages, making it incredibly easy to use as a reference guide. So if you're serious about becoming a skilled programmer, grab a copy for yourself, or even consider looking at my premium coding kickstart course to get your hand on either one of these. Check out the links in the description below. All right, so let's get into this a little more. In a simple linked list, each node contains at a minimum 2 things. 1, some data content, and 2, a reference that points to the next node in the list. Now the last node in the list just points to null. That's it. The main difference between a linked list and an array or array list is that array memory is allocated in contiguous blocks all at once, whereas linked list elements are allocated one node at a time. This bare bones example is called a singly linked list. A doubly linked list, on the other hand, has nodes that contain references to both next and previous nodes in the list. This takes up a little bit extra memory, but allows the list to be traversed in both directions. Note that in both singly linked and doubly linked lists, extra memory is required to store the references to their adjacent objects. And do recall that an array doesn't need this extra memory because the elements in the array are stored sequentially in that contiguous block of memory, whereas elements in a linked list are potentially scattered all over. Looking at the code for the linked list, there are 2 classes involved. The linked list class, which has a reference to the head and the tail node if it's a doubly linked list. It also contains a good chunk of the business logic for adding, inserting, removing, searching, etc. The second class is the node class that contains the actual data as well as the reference to the next or previous node like we talked about. You can see here that head and tail are just references to the first and last node of the list respectively. So let's dive in and build a singly linked list in C#. We'll start by creating a node T class that will represent each element in our list. Then we'll create the wrapper linked list of T class around the nodes. I'm also going to continue in step with our last video and make the linked list of T implement our iSimple list of T interface, and in practice what I preach in terms of test-driven development. It's super tempting to want to take the lazy route in these kinds of demos, but I really believe that implementing some of these best practices early on is going to accelerate your career and mastery to this craft. So let's do that and look at some code. Okay, so implementing our simple linked list. I'm going to add a class for that. Here we are, and I said there was 2 classes we need to implement, the simple linked list of T, as well as the node class. The node class I'm actually going to do in here just as an internal, since the node is only for my linked list. I don't want it to be used outside. So in C# you can do that in nested classes. Again, I've got GitHub Copilot just to help stub out some of this code, make it go a little bit faster. I also said we were going to make this implement the interface that we did in our last example, the iSimpleList interface. So let's grab that and make that implement. It's going to say you haven't implemented these interfaces. So with my cursor selected, hit Control dot, and I can just say implement missing members. This is ReSharper. Again, Visual Studio will have one as well. And there we are. Now I've got some unit tests from my simple array list, and I can actually reuse these to help my test-driven development with the array list. I think what I'll do is I'll copy this into another test class and just blow away what I don't need. Copy, and then I'll add a new class in my test project. Go check out the last video if you want to see how we got here thus far. Okay, I've copied my code from the other class. I'm just going to delete what I don't need. There's no notion of capacity in the linked list that I'm going to create. A lot of these methods are going to be pretty similar. I'm just going to create a new linked list. In this case, I'm just going to add stuff to it and make sure that it's there, checking that the sizes are correct, as well as the elements at that location. I don't need to worry about increasing that capacity. That was an array list specific thing. So let's start with this, and then I'm going to hit Control H to do find and replace. And I'm going to find simple array list and just replace it with simple linked list. And I've got some basic tests to help get me started. Nothing super complete by any means, but enough to get going. I've got ReSharper installed, which are these options down here, but I can also just run my tests right through Visual Studio. And in the last video, I talked about a free code coverage tool called Find Code Coverage. So I've got that enabled here just for your benefit as well. The ReSharper one looks a lot better, but as you can see, here are my unit test sessions. Test Explorer. Test Explorer is from Visual Studio. Unit test sessions is from ReSharper. So as I ran the code on my data structures test project, all the tests that I just added are failing because, of course, they're not implemented, and they're telling me that as such. But if I go down to my Find Code Coverage window, so that's after you find that in the extensions and install that, you can get code coverage information there as well. I'm going to go back to using ReSharper for the rest of this demo, and then we can start implementing our linked list. Starting with the node, let's get a constructor, CTOR, double tab, gets me that. I'm going to need properties. I need the T item, and then we're just doing a singly linked list, which is next. But if I were doing a doubly linked list, I would add a previous there as well. I'm going to make this node class private so that only the linked list class can see it, and then all of these elements public to that class. So in the constructor, we just take the item that was passed in and we set it to our property. This little squiggly is saying that item can be private, but that's just because I haven't had code down here in the actual linked list class that references it yet. We'll just ignore everything, all the warnings here in the private class for now. By default, this next property, because it's a reference type, is just going to default to null. So I don't have to put this line here, but I will for the sake of demonstratability. And if I was a purist, I would probably have a test class for the node as well. But again, this is just such a small container for the purposes of this demo, keeping it brief. I'm going to not do that. Okay, working on our linked list, I said we need to keep a reference to the head. That's just going to be internal to this class. No one really needs to know about it. And I think I might go back to my unit test class, and I want to add a unit test for my linked list that checks when you create one of these from scratch. I want to make sure that the size is 0, and this head shouldn't really be pointing to anything. So we might have a specific case for that. So let's go add a test. We'll say default constructor has size 0. Again, I'm just using ints for my generic type there, but now I can confirm that 0 is the size. And then I think it'll be easy enough to add the item first. So what do we do in the case where the linked list is empty? Well, head is our begin. So what we want to do is check if head is even pointing to anything. If not, what we're going to add is going to be the new head. So if head is null, head is now our new item, but we're not assigning a T to the head, we're assigning a node. So what we want to do is make a new node of type T, and we pass in that item. Otherwise, if head is not null, then we need to go traverse the list and find the last node in the list. We'll loop through it. This is exactly what I want. While current.next is not equal to null, go set the current to the next thing. Now we should be at the end of our list, and we can say current node's next node is our new item. All right, and at this point, I think I'm gonna resolve some of these errors. So what this is saying, it's a non-nullable property must contain a non-null value when exiting the constructor. I do want my head to be able to be nullable. It's going to compile just fine, but this is a feature in newer C#. So anyway, if you hover over these things, hit Control Dot, or hit the little light bulb thing that comes up, it will come up with some ideas for you to fix it. So here I want to change this to nullable. So that's that property there. And also what I'm going to do is just change the casing on this. Instead of all caps, just use Pascal case. Another thing I realize is because I have declared what T is inside the simple linked list class, and the node is a subclass of that, I actually don't need this T here. And that's what this is telling me. This type parameter T has the same parameter from the outer type. So just to avoid that ambiguity. And then this is saying all these can be made private because it's a subclass and it has access to those members anyways. So again, hover over that, hit the little light bulb on the side, and say make private. And then here I don't need the generic. This class is no longer generic, so I can't use it there, and I don't need it because I already got T items set there. And as well here, node is no longer generic. Look at that, tab to remove the T. I didn't even know that was a feature, but great, I'll take it. Quickly clean this up. What I want to say is, if my head is null, I just set the head equal to a new item and return, move on. So resharper now is telling me that this else is redundant, and that's precisely why I put that in there, so I could just get rid of that. Control K, Control D for formatting. Reading this little warning, expressions always true according to nullable reference types annotations. So again, this is a newer C# thing. Basically what it's saying is current.next, the next node is a nullable, is not nullable. And so if I manually allow that here by putting the question mark, now this error should go away, or warning rather. Got my resharper set to auto cover new and outdated tests on build. So let's see. Last thing for the add here, and then I'll do a build and run some more tests, is anytime I add an item, I want to increment the size variable. And so this is giving me an error saying that it's get only. So what I want to be able to do is make a private setter so that I can set it within this class, but not from outside. And again, right here, Control-Shift-B, run a build. That's going to run my tests, and it looks like some of these tests started passing, so that's great. I also want to look at my code coverage. So I'm going to pull that up here and show that in the same window. And the class I am particularly that I care about are my linked list tests and my simple linked list here. Not seeing any code coverage for my linked list or my old array list class for that matter from the previous video. So I'm just going to manually run a cover unit test task here and see what we end up with. Okay, that seemed to help make it come back up to date. So I've got 50%, what's that? 69% of my linked list class. Nice, so we'll just keep implementing until these tests are passing, and we'll see if there's any code coverage missing. So next thing to do is check the accessor, or the indexer rather. This case here adds one to the list and then goes and retrieves it. Let's go implement that. And as we do this, one thing I want to do is highlight the algorithmic complexity. Okay, so that's just how long it takes to do something. And there's this notion of big O notation, which describes how long an algorithm takes to run in order of its relative order of magnitude of complexity. And so what we'll do is we'll implement this, and then we'll do a quick compare and contrast with the array list, and you'll see the difference. So what we're going to need to do here, again, because the linked list only has the reference to the head, is we're going to have to start at the head and make a for loop and just say, for the index, keep looping over to and getting the next one and the next one until we found the right node. And I think I've got a clever idea here using some C# null propagation. So what I'm going to do is the first node is the head. The head could be null here, by the way. But what we're going to do is, so in the case where the index is 0, it should just skip this for loop. But what I'm going to do is inside the loop, I'm just going to say the current equals current (next). So what this will do is if current is null, then it's just going to propagate the null of, instead of causing a null reference exception, it's just going to set current back to null, and that's going to continue. And all I really care about at the end of the day, and you can see where GitHub Copilot is predicting my mind here, it's just saying that if the current node is null, which is probably what I'm going to do. I don't care about whether the item is null, but if the current node is null after we've tried to get through however many indexes here, and this is admittedly a dumb way to do it. In fact, this could probably be optimized by making sure that I could check the index compared to the size. So that would be a little bit smarter, but this should work as well. I'm basically going to say that if the current node is null, then I'm going to throw index out of range. Otherwise, I'm just going to return the item right in the current node. Okay, and I was wondering if this was going to be an issue. So it's saying that item is private. I assumed that it told me that I could make it private, but maybe that's just because nobody was referencing that property yet. So again, control dot. Let's make it internal. We're going to build, and we've got a little bit more coverage here and one test left. Let's go make that pass. Okay, here we're just adding an item and then changing its value from 1 to 2 and checking that. So let's go implement the setter next. This is probably going to be pretty similar, so I'm just going to copy paste some code here to get started. Rid of the return. And the logic here should be actually pretty much the same plus the setting of the value. So I wonder if I can actually just call the getter part of this property in my set. I probably don't even need all this. The problem if I do that though is it's going to return a T for the item, but what I really want it to return is a node. So I think what I'm going to do is I'm going to refactor this out into a helper method. Again, this is where unit tests come in handy, especially at the beginning. Look at this, get node at index. So yep, it totally knows where I'm going with this. So essentially taking this logic here, putting it up there, and then I'm going to make sure that my index out of range exception happens there as well. And now all I'm going to say is get node at index, whatever the index is. Make sure that node is returning nullable there. We'll just break this out into two. Still a similar problem from what I had before. T cannot be made nullable. And I see the problem. I was hoping that by this potentially throwing an exception, I wouldn't have to worry about the nullable types here, but I think I will have to do that. So I'll make get node at index return a nullable node, and then I'll just check if the node at that index is null and throw the exception there. And after that, I've guaranteed the compiler knows that node is not null here. Look at that. As I hover over it, it says node at index is not null. So it's got some static analysis to where it knows this can no longer be null. So accessing an item off of a nullable type isn't going to result in that C# warning. Back to the setter. Now, instead of copying and pasting, 5 lines of code, I'm copying and pasting just a couple here. Again, I verified the node is not null after this check happens. So all I want to do is take the value that was passed in from the setter using our C# keyword value, set it into the item. Run a build, see where our coverage is at. Didn't seem to go, so I'm just going to say cover unit test up here. Okay, everything's passing, but we still got some red lines here. So with your unit test coverage tool, you can look, usually they have these lines in the side that tell you whether a line was never hit. Like if I hover over one of these gray ones, it was uncovered by test. So I really need to beef up my tests. They're very simple, enough to kind of get me started. But it looks like because I'm only ever adding one item, all of this logic for looping through the linked list never happens, and so it never gets tested. So again, great tool to have. Let's go beef up those tests. But let's stress it out. Let's just add 100 random items of ints. We'll do that with a little loop. We're going to build with our new test. And we've just visibly seen the amount of green increase, and our add method is now fully covered. So that's great. So what else are we missing? Looks like we're missing a check on both the getter and setter of this indexer, checking for a value out of range, throwing an exception. So we can add a test for that, sure. And I've got to assign it to a variable since just calling the indexer isn't a complete expression. So C# is giving me an error there. It's probably a better way to handle this. Okay, my code coverage increased. Go back and look at my test. I can see that this line is covered. So let's fix the one for the setter too. Just going to take the lazy way out here and add another assert right in the same method. Run a build, cover my tests. Very good. Now everything in this class is tested except for 4 lines at this get node at index. So I made this private, so I'm not going to be able to access this method directly in my unit tests. Probably could architect my way around that, but I think what I'm going to do instead is make sure that this gets called by trying to access elements after the list has a bunch of stuff in it. So I'm going to borrow this test where I added 100 items and check the size. Now I'll just go check the values of all 100 items. I'll just loop through the 100 and make sure that all the values are what I set them to. The kicker here is that I'm calling this indexer. I think that's going to test everything I need it to. So yeah, I'm noticing sometimes when I run a build, this updates, sometimes it does not. So at this point, we've got 100% code coverage. So there it is, linked list. Now I said we do a comparison and contrast with the array list. And what I want to specifically show is this indexer. Specifically, when you try to get a node at the index, look at how much work it takes. You can't just say, go get me the node at this index and instantly get it. You have to start at the beginning and you must loop through. In the best case, it could be the very first one. In the worst case, it could be the very last one. On average, it would be, if your list size, if we call that n, on average, the complexity for this is n over 2, but we don't care about those coefficients with the big O notation. So this is an order of n operation to get a specific node. Whereas if we go look at the linked list, here's the indexer for that one. Again, it's an array underneath, and with arrays, you know the address of the array, and because it's a contiguous block, you just add that many to the address of where this array starts, and you can calculate where I need to pull the value from, and you just get it. That happens in constant time, and so we say that's a big O of constant time. So we like that in algorithms. With linked list, having to loop through this is a real pain, and I think that's probably one of the reasons why linked lists are not used as much, at least in the real world. All right, so here we are. Hope you enjoyed that look into linked lists. Couple key takeaways. We introduced this notion of algorithmic complexity, and the choice of your data structure will influence that. So as we continue to explore more of these, pay attention to that. And then also remember how the iSimpleList of T interface that we created in the last video and the ArrayList test came in a lot of handy today just to speed things up. So stick around this playlist. We got lots more fun data structures to cover. Remember, grab my C# object-oriented cheat sheet for free. It's in the description. Or if you want a guided kickstart to C# or Java and object-oriented programming by me, you can check out the premium course as well. Hey, leave me a comment if something was helpful or if I can help clarify anything else that we talked about today, if it was confusing. Do me a favor, hit that like button and subscribe if you find content like this helpful. And I'll look forward to seeing you in the rest of the series. Take care.